if we take an arithmetic sequence and add up all of its terms, then what we have is an arithmetic series. To add up the series, we have two formulas here. The fact that you have an arithmetic series, you have a common difference that's being added to each and every single term. It makes it easier because there is a pattern. It makes it easier to add using a simple formula. There are two formulas that we're going to be using today. One is this, and the second formula is this. Okay? So let's take a look at the first one.
Can they just be used interchangeably?
Yes and no. You'll see. Okay, in the first case, we have a series. We have the first and the last part of the sequence, and we just want to find the indicated sum here. Let's see what information we do have. I have that A1 is equal to -3. I have that AN is equal to 157. Now, for my formulas, what I need is N. N is the number of terms that are in the sequence. In this case, I can't tell just by looking because I don't know how many numbers have been skipped over here. However, I have A1, I have AN. I can easily find what D is by subtracting two consecutive terms. So in this case, D is equal to 5. Now I can use my initial formula from the beginning of this lesson to figure out what N is. So AN is A1 plus N minus 1 times D. 157 is equal to -3 plus 5 minus 1 times D. D is, no, I did it again. Maybe not. Okay, so N minus 1 times 5. So N is 33. N is 33.
32.
So it ends up at 165 is equal to 5N. Because this is -8, and if you add it here, it'll be 165 equals 5N, so N is equal to 33. Now that I have N, I can easily use formula number 1 to solve this, and the formula says Sn is equal to N over 2, A1 plus AN. So 33 over 2 times A1, which is -3, plus 157.
Do we not have to plug 33
You do. I just haven't done anything yet. So S subscript 33 is equal to, at the end of the day, 2,541. Okay. So we now know that there are 33 total terms, and the final sum, when you add up all 33 terms, is 2,541. In this next one, we want to find the 17th partial sum. Okay? Here, we're not given the last term of the sequence. Okay? So it's more reasonable for us to use the second formula because it doesn't include AN. For formula 2, the formula is Sn is equal to N over 2, 2A1 plus N minus 1 times D. Because I'm looking for the 17th partial sum, N is equal to 17, so I have that. A1, I have it, it's 53, and I need to find D. D, I can easily find it, it's 31 minus 53. So D is equal to -22. So now we're ready to plug all this into our formula. Sn, because it's the 17th partial sum, can be written as S17 is equal to 17 over 2, 2 times A1, 53, plus n minus 1, 17 minus 1 times d, negative 22. Okay? Everybody okay over there? When you put all that into the calculator, we have that S17 is equal to 17 over 2 times negative 246. So S17 equals negative 2091. Now, this last one is a bit different. We're starting from n equals 10 and going to 32. Okay? So it's our first one, A1, is when n is equal to 10. Right? So A1 is 10 plus 6, 16. A2 is the next one, 11 plus 6, 17. And so on and so forth. AN, the last one, is A32, which is 32 plus 6, 38. So we're going to use the first formula again because we have A1 and we have AN. Now, how much is N? N is how many terms are in this sequence, right? So if I start with 10 and end at 32, how many do I have?
You have 22.
This is not, I'm sorry, this is not A32, this is AN. We're going to label it AN.
Wouldn't the other ones be 8 times?
Well,
A1 to AN. So if you have homework that starts at number 10 and ends at 32, how many problems do you have for homework?
22.
Plus number 10, it's 23. So if you start counting 10, 11, 12, 13, all right, it's 23 problems. So to find N, you take the higher number minus the lower number, and you add 1 in order to include that first number. So N is equal to 23. Now we're ready to plug this into our formula. Sn is equal to n over 2, A1 plus AN. So S23 is equal to 23 over 2, 16 plus 38. Therefore, S23 is equal to 621.